Okay, so this is our third and final video of practice problems for this section. And again, go to the ones that you want to see through the solution or listen to the solution or check your work and then just find which ones you need to go back to. So this one is unique because we do need to complete the square. But what I'm going to do is I'm going to actually let u be 4x because I know that this is like 4x is a quantity squared. And I'm thinking inverse tangent because I know it's quadratic in the bottom and a constant on the top. So so I'm going to let u be 4x. So our du is 4 dx, which means I need 3/4 of the du to get 3 dx there. And then before I determine my a, let's go ahead and figure out what this is as a completed square. So right now, so I'm doing this one just slightly different. So that's 3/4, and then it's going to be 1 over, and this is u squared. Now 8x could be represented as 2u, and then we still have our 37. And then I could now complete the square on u. So it's 3/4, 1 over, well, I guess that'd be u squared plus 2u plus 1. If I want to show that step there. And then plus 37 minus that 1. So then I can see that's the integral of 3/4, and it's 1 over u plus 1 as a quantity squared plus 36. So now I can see my a value would be 6. So then when I do the antiderivative, I have 3/4, and it's going to be arctangent, which is 1 over a, and then arctangent of u, which is really u plus 1 over a, plus c. And then what was u? U was 4x. So that becomes 3/24 or 1/8. And then arctangent of 4x plus 1 over 6 plus c. Yeah, and if you were wondering, well, why didn't you do another u substitution here? Since technically u plus 1 is not just a u. But again, if you think about letting, let's say, w equal u plus 1, its derivative is linear. It's a 1-to-1 ratio derivative. You should be cautious if there's a coefficient right in front of u. If there's something that gives you a derivative that's not just equal to 1. Okay, number 12 I like because it's another practice of completing the square, but with that negative in the square root. And again, I'm seeing quadratic within the square root, and it's constant on the top. So I'm definitely thinking arc sine. And so then let's go ahead and complete the square here. So we have 0 to 3. And then we have 6 over the square root of 27. And then we like to put our x squared first. So we factor out the negative. And it becomes plus 6x. Half of that is 3, and 3 squared is 9. That's really a negative 9, so we're going to add 9 to balance that out. That makes it a nice perfect square of 36. So we've got 0 to 3 of 6 over the square root of 36 minus the quantity x plus 3 squared dx. So then u should be x plus 3. Although maybe you realize we really don't need to do that because our du is just dx. And then we have 6 of them, we'll get 2. And my a value is also 6 because 6 squared is 36. So now I get the antiderivative. And if u is x plus 3, 0 plus 3 is 3. And 3 plus 3 is 6. And then we get 6 over the square root of 6 squared minus u squared du. And we've already converted to u, so we don't even have to go back to x's. So this 6 stays. There's no 1 over a for arc sine, so it's just arc sine of u over a when evaluated from 3 to 6. Now I hope I came up with nice answers, nice numbers here. So this would be 6 arc sine of 6 over 6, which is 1, minus 6 arc sine of 3 over 6 of 1/2. Arc sine of 1, think about where the sine is 1 is equals to pi over 2. So this is 6 times pi over 2 minus 6 times arcsine of 1/2, which would be pi over 6. So we get 3 pi minus 1 pi, which is equal to 2 pi, is my answer. All right, 2 to go. So this problem, so, exponential functions are their own derivatives. And so I'm thinking, okay, that could make sense. I could make u the entire denominator, but the problem being that the derivative then would be a 4 to the x, and I have a 2 to the x there. So maybe I recognize that 4 to the x is the same thing as 2 to the x squared, right? Because when you raise a power to a power, you would have multiplied. So that would have been 2 to the 2x. And 2 to the 2x is the same thing as 4 to the x. So really, this is kind of like a u squared plus 4. So I'm going to let u be 2 to the x. Because then du is 2 to the x, well, times natural log of 2 dx. And notice, right, that will make sense to make that our du there. So divide the natural log of 2 over. So 1 over natural log of 2 du is equal to 2 to the x dx. So then when I look at this, my a value, 2 squared is 4. So a is 2. So now this becomes the integral. I have 1 over natural log of 2 du, and then it's 1 over u squared plus 2 squared. And then since u was 2 to the x, so 2 to the 0 is 1, and 2 to the 2, which is 4. So then this becomes 1 over natural log of 2, and then this is arctangent, so it's 1 over a, so 1/2, and then it's arctangent of u over a, so u over 2, when evaluated from 1 to 4. So then, erase this guys here. So this 2 can go with this. So we can make it 1 over 2 natural log of 2. If you want to make that 1 over natural log of 4, that's fine. Arctangent, I'll use parentheses here. 4 divided by 2, so it's 2 minus arctangent of 1/2. Now, 1/2 is a great ratio if you're sine, but not for tangent. So I would just leave it like this. This is fine. Okay, very good. And then our last example, one that arc cosine in it already. Maybe it looks intimidating. It shouldn't, because that makes it a perfect u. So let's go ahead and let change color here. Why not? Let's let u equal arc cosine of 10x. The derivative, remember, is negative 1 over, and then it's the square root of 1 minus 10x squared. And then chain rule, derivative of 10x, which is 10. So we don't quite have that. We're off by a negative 1/10, so we'll divide that over. So negative 1/10 du is equal to 1 over the square root of 1 minus, there's your 100x squared dx. So really, this whole thing becomes my du, and what's left, that whole quantity right here, arc cosine, is my u. So if I rewrite this, I get the antiderivative of negative 1/10 du, and it's just a u. I mean, right? Something so complicated became just a u, and its antiderivative is u squared over 2. So this becomes negative 10 times u squared over 2 plus c, or that's negative 1/20th. And then what was u? U was arc cosine of 10x. It's a quantity squared plus c. So, initially, I think students, at least in the past, students have been maybe a little intimidated when they see arc cosine, arc sine, but don't, because if that's in your integral, that makes it almost like a gimme that's going to be your u. Okay, so, just to reiterate, the main goal of this section of these 3 videos was really to give you practice recognizing which technique, which strategy, what antiderivative are you trying to solve.